Hi, we're live at Goddard Space Flight Center. I'm Erin, Kisliuk, and we are here today talking about exomoons. There's been a lot of excitement this week between NASA's 60th anniversary and this new potential exomoon, so I've got the experts here to talk to you a little bit about it. I've got Dr. Jennifer Wiseman, and I've got Dr. Nicole Cologne. And send in your questions to #AskNASA, and we'll get to just as many as we can. So let's jump right in. Jennifer, what is an exomoon?
Well, Erin, an exomoon would be a moon that's outside our solar system. The exo part is the outside part. And as you know, we've been detecting thousands of planets outside our solar system over the last couple of decades or so. It's very exciting. But we've always wondered if any of those planets that are orbiting stars other than our sun could also have moons like many of the planets in our own solar system have. And now we have some intriguing evidence that we may have found one such system.
That's really exciting. So a new moon in a new place. Nicole, how do we go about finding something that we've never found before? How do you find an exomoon?
That's a really great question. There are several ways to find exoplanets, and one of the ways that we would prefer to find them is to take a direct picture of it so we can see it, it's in all its glory. But that's really difficult to do because the stars are so bright, and direct imaging, often you need to block the light from the star, and the planet itself is so faint and so small in comparison that we have to use what we call indirect methods to instead detect these exoplanets. So in this case of this exoplanet and exomoon system, we use something called the transit method. And so what this is we look at a star and we measure its brightness over time. And essentially, we're looking to see regular dips of brightness in the star's light. So as illustrated here, when you have some type of size planet, like a Jupiter-sized planet, which is the case here, the Jupiter comes in and it blocks some fraction of light from the star, causing a big dip in the light. But then, in this case, we also saw an exomoon signal, which happened because we saw a tinier dip of light that came around the same time as the transit of the Jupiter-sized planet. So here, there's another smaller object that causes a teeny tiny little dip over here. And so this is what we saw when we discovered this candidate exomoon system. But taking a step back, what telescopes did we actually use to do this? Those were the Kepler Space Telescope and the Hubble Space Telescope. So Kepler ran the original survey using the same transit method to find thousands of planets, as Jennifer mentioned. And Kepler stared at one part of the sky to do this. But in all those planets that Kepler found, only one viable exomoon candidate was discovered. And so that's why it was so exciting to astronomers. And after that, astronomers decided to use the Hubble Space Telescope to follow it up and verify the signal that we originally saw in the Kepler data. So Hubble was able to provide a more precise measurement. It has more sensitive instruments, basically. And so we were able to recover this signal and verify that we do indeed have a viable planet and exomoon candidate system now.
That's so exciting. So many different telescopes working together. I just want to remind everybody just joining us now that we're at NASA's Goddard Space Flight Center and we are talking about exomoons. And if you have questions, send them into #AskNASA, and we're getting to just as many as we can today during the show. So Jennifer, we have our own moon and we know about other moons in our solar system. Is this moon like the moons we already know?
Well, Erin, we don't know too much about this system yet, but we know a little bit. We know that the size of the moon is much bigger than the moons that we are accustomed to in our own solar system. I mean, we have a huge variety of moons in our solar system, over 170 moons. But they come in many different sizes and many different types of environments. Everything from the hot volcanic moon of Io to these ice-covered moons, and even moons that are, comparable to our moon or bigger. But we don't have the type of moon that we're seeing in this system. This system seems to have a moon that's really about the size of Neptune. It's huge. and it's orbiting a planet that would be like Jupiter basically in size. This moon would probably be more like a gaseous body, so we don't really have a gaseous type moon that we know of in our own solar system. So in that sense, it would be very different from the types of moons we're accustomed to studying in our own solar system. However, in one way, it's not all that different from what we're accustomed to, and that's in the sense that this planet and potential moon is orbiting a star that's not too different from our sun, and orbiting at about the same distance from that star that our Earth is orbiting from our sun. And so it has a similar length of year, the planet does, and probably a similar type of environment in the sense that it is in what we call the habitable zone around that star. That doesn't necessarily mean there's life there, but it means that the temperatures there would be moderate enough that you could potentially have liquid water in that region. However, given that it's probably a big gaseous thing, it's not going to be like oceans and lakes. So mostly it's different from what we're accustomed to here.
Thank you. So we got a new moon in a new place. We're learning all kinds of new things. And like you said, Nicole, it took 2 telescopes to figure this out. So what's the plan going forward? Do we have any more ways to gather even more evidence from maybe other telescopes?
Well, first we hope that Hubble itself will be able to look at this planet again. The issue with this is that because Jennifer just mentioned it has such a large orbit, almost as long as our own year, it takes a long time before it transits again. So it only transits every so often, so we can only look at the signal every so often. And so Hubble might have a chance to look at this again next May, actually. And beyond that, the James Webb Space Telescope is expected to launch in a few years. And that has also very sensitive instruments and a large mirror that can collect a lot of light to get very precise data. So we can, again, look to recover this same signal and help verify this, this exomoon candidate that has been identified. And in addition, beyond just looking at the same system, the TESS mission just started collecting data recently, and it launched in April of this year, and TESS is the Transiting Exoplanet Survey Satellite. And since July, actually, it started science. It is basically doing a nearly all-sky survey compared to the Kepler mission, which observed just one part of the sky. TESS is looking at almost the entire sky for exoplanets, doing the same exact thing, looking for dips in the light. And in this case, TESS is looking at a lot of bright stars, a lot of nearby stars, so it's looking at a very different sample of stars than Kepler looked at, but there's still the possibility that we will find lots of planets, and maybe some of those will have exomoons around them.
So I guess we'll all have to stay tuned. And speaking of stay tuned, maybe you're just tuning in. We're live at NASA's Goddard Space Flight Center. We're talking about exomoons. Crazy. Send your questions into #AskNASA, and we'll get to just as many as we can throughout the show. One of the questions that I had seen from the press release when it came out on Wednesday, people were asking about how far is this away from us?
Oh, good question. So we think this system is about 8,000 light years away. Of course, a light year is the distance that it takes for light to travel in a year. And so it's not right around the corner from our solar system, but it is in our galaxy and not too far away cosmically speaking. So it's in the constellation Sagittarius, or no, what's the constellation?
Oh, it's in Cygnus.
Cygnus, sorry, it's in Cygnus. This is the region of the sky that Kepler was observing, and so that's why the system was found in the first place by Kepler. And so it's not easy for us to see, especially this candidate of an exomoon. We have to have powerful telescopes, but it's in our own galaxy.
So it's not terribly far away.
No.
Astronomically. So it's not so far away. Another question we were getting, of course, is could there be life?
Could there be? Yeah, that's a question everybody always wants to know. And again, this system, this planet and this moon, exomoon, is orbiting at a distance from its star that means that at that region, the temperature it has could be a temperature where liquid water exists, or it is a temperature where liquid water exists. But these two particular objects are so large and massive that they're basically like balls of gas. You know, they're gas giants essentially, and they're nothing like our own Earth. You know, they don't have this rocky surface that you can really walk around on. So the prospects of life on this planet and this moon itself is very slim.
Yeah.
But where there's one planet, often we find more. So there might be more planets in this system where, you know, that could be rocky. We just haven't had the sensitivity to detect them yet. So that's something that, you know, we'll see in the future if we're able to tell whether or not there's additional planets in the system that could have ingredients for life.
Well, I guess we'll have to stay tuned. And we're actually starting to take in some of your questions. Keep sending them, and I've got some really good ones here. Hashtag Ask NASA, of course. So Jennifer, we were just talking about the temperature of the moon. What is the temperature of the moon?
Well, again, we don't know too much about this moon yet. We know roughly its size, its mass, it's huge. But we don't really know all these details, but we can kind of estimate. The researchers who were detecting this object estimated its temperature based on its distance and likely composition. So we think it's a balmy, maybe 80 degrees Fahrenheit up to 170 degrees Fahrenheit. So, you know, warm but not boiling hot, yes.
Perfect for life. So Nicole, was this a surprise for scientists when we saw this thing? Was it shocking, or were we looking for it? What?
Well, you know, thinking about our own solar system, where we have a lot of planets and we have a lot of moons around those planets. Jupiter and Saturn both have many moons around them. You know, there's so many moons in our own solar system, essentially, that finding even just one outside our solar system around another star, around another planet, is not that surprising. It shows you, though, since we've only found one, how difficult it is to find these small signals. And so, you know, I'm sure over time we can find more, but who knows if there'll be anything like our own moon, Earth system. You never know.
All right, so a few more questions coming in. Jennifer, is it possible to one day find exoplanets that have binary orbits like Pluto and Charon in that system?
Well, certainly it's possible. I mean, this is very interesting. If you have, you know, one body orbiting a star and then something perhaps orbiting that body, as we do in a moon-planet system, but then there can also be sort of binary planet situations. The definition of that is not always completely clear. So it's certainly possible in this system that we might have a binary planetary system. In this case, though, the candidate moon that we have is something like, you know, 1.5% the mass of its planet. It's similar to the Earth and our moon ratio of mass. The size difference is pronounced between this moon and its planet. And so it's more, I think it would be more accurately described, if this is confirmed, as a moon planet system as opposed to a binary planet system, simply because of that difference in size and mass ratio. But we need a few more observations to learn more details.
And it's interesting you should say that, because the very next question that I got in was, how big is the moon?
Well, it's large. I mean, we think, again, we can compare it to something like Neptune in our own solar system. So, you know, we're not used to having moons that are bigger than that much bigger than planet Earth in our own solar system. So it's really hard to compare. This is, you know, think about the Earth-Moon system that we're accustomed to, and then expand it. And then you've got this a huge system, a very large Jupiter-like planet with a Neptune-sized moon, both gaseous type bodies as this system. So it's much larger than what we're accustomed to any type of system in our own solar system.
It's exciting.
Yeah.
You know, it's nice to find new things. Speaking of which, we had a Facebook follower asking if we plan to send a probe to this exomoon. Nicole, what do you think about that?
Oh gosh, I mean, that would be amazing if we could do that. But Jennifer mentioned before how far away it is. It's 8,000 light years away, which means that even if we could travel at the speed of light, it would take 8,000 years to get there. So, you know, it would be, you know, one of these awesome, nice to have things, but I think it'll be a while before we have the technology to be able to send a probe there, unfortunately.
We don't have warp drive yet.
Yes, we need warp drive.
Continue to send in your questions. We're taking them live from social media using the hashtag AskNASA. So the next question that I got was from Facebook, and somebody asked, why should we be limiting the search for life to water/carbon-based planets?
Very good question. So, you know, we don't know what we don't know. So life forms could be very different from the type of life that we are accustomed to on planet Earth. We've all seen a lot of science fiction. But there are some good reasons to think that complex life would probably be carbon-based and probably need some connection to liquid water. That's certainly what we found on planet Earth. And we also are able, at least from our experience here, to recognize what that type of life would do to its atmosphere, such that we could detect it from a distance and look at the atmospheric characteristics and know that there must be some kind of biological activity going on. So those are some of the reasons why it makes sense to look for life that has some similar basis to the life forms that we are familiar with on planet Earth.
Makes sense. A lot of questions from Facebook, good ones. So how do we measure, how do we go about measuring the size and distance to an exoplanet or an exomoon?
So the size is it's essentially, we're using the same way we used to find it in the first place. So it's something called the transit method, where basically the planet blocks a fraction of the light of the star. And based on how much it blocks, it's kind of like a ratio of areas. So you can say, oh, 1% of light is blocked, which means some object of some specific size had to block that size, that amount of light. And so in that way, we're able to measure the radius of the planet. That means we also need to know the size of the star in order to compare the two. But we can know that from using observations from even other telescopes as well. So there's like this whole army of telescopes you need to be able to really find the planets and measure their properties and you know, learn more about them. And in terms of the distance, right, that was the other part of the question. So how we measure the distance, there was actually a mission called Gaia that is recently collecting data to measure positions of stars in the sky. And based on measuring the positions of the stars, we actually can measure kind of like this angle of how much they move. And that actually tells us the distance away from Earth. So it's really, again, an army of telescopes that operates, you know, in concert to provide all this information to get us the size, even mass, you know, distance, everything. So it's a lot of work, but it's definitely worth it.
Oh, we're lucky we have a great team.
That's right.
So we've got another question from hashtag AskNASA. It is, how much stronger is the gravity on this exomoon compared to than Earth?
Well, that's a very good question. I would think I would have to sit and calculate that out.
Put you on the spot, right?
Put me on the spot. So we know that its mass, were they asking about the moon or the planet? So
it looks like compared to Earth. How much stronger is the gravity on this exomoon compared to Earth?
Okay, so this moon is basically larger than Earth. It's basically the size of Neptune. So it's going to have a stronger gravitational field based on the mass difference between the moon and the Earth. I can't actually tell you that because we don't know for sure the actual mass of this moon. But it's going to be stronger. And it's also going to be an odd thing to imagine because it doesn't have a solid surface. So if you're thinking about, you know, jumping up and down on this moon like you might do on Earth's moon if you were an astronaut, you're not going to have the same experience. So it's stronger, and that may have actually interesting implications for the layers of atmosphere in this moon. So if we have future telescopes where we can actually measure the composition of the atmosphere of this moon and compare it to, let's say, planets in our own, gaseous planets in our own solar system, we may be able to understand something about how that moon has been formed, what its nature is, and how that strong gravitational field is affecting how the layers of gases are arranging themselves in this moon. So I look forward to being able to understand the effects of the gravitational field and maybe even a magnetic field when we have future observations. Yeah.
So we're just going to have to wait and see for a lot of these questions. So this is actually a really interesting question. If our own Earth was this far away, would we be able to detect it?
So if our Earth was like 8,000 light years away, I guess, at the same distance, that's a good question. So the initial planet that this moon orbits around is a Jupiter-sized planet, which is something like 10, 11, 12 times the size of Earth. So it causes a pretty large dip in light. So the Earth, being that much smaller, would cause a much smaller dip, like 1/10 of what that Jupiter causes. So we would basically need, very, very precise instruments. And Kepler did discover several Earth-size exoplanets, but then to have, an exomoon around it, that's something we haven't discovered yet. So, it's tricky, is the answer. It depends on a lot of things, but it's not impossible. You just need to make sure you have the right, telescope, basically.
Okay, let's see. Continue sending your questions into #AskNASA, by the way. We will get to as many as we can, and we'll get to some after the show too, I'm sure. So how does the gravity, well, we already discussed gravity, how's the electromagnetic field of that exomoon compared to Earth? Do we even have any information on that yet?
Well, that's a great question, because that would impact all kinds of things about the environment, about that exomoon. So we don't have a lot of information about this whole system, but as I mentioned earlier, we think that the star that this planet and potential moon are orbiting is not too different from our sun. So it's going to have some of those same characteristics of the sun, which would include magnetic field activity that might in fact interact occasionally. The stellar activity may interact with this planet and its moon, its system, just the same way as our sun has certain activity, flares and so forth, that interact with our Earth-Moon system. And then it's quite possible that this planet that this moon is associated with would have a magnetic field. That magnetic field would impact its moon, and it would affect the environment there. And that would affect how that system is interacting with flares and particles, cosmic rays coming from its parent star. So we don't know yet what the magnetic field might be around that system. We know it's going to get the same, ballpark radiation from its parent star as we get from the sun in our Earth-Moon system. And this will impact whether there is any sort of habitability in this region. At the very least, it'll be very interesting to study. So we keep talking about future telescopes, but I'm very keen about this direction of astronomy, because we are using the telescopes we have, like Hubble and soon TESS, to learn what we can. But future telescopes like the James Webb Space Telescope are going to be able to give us more details about the nature of this exoplanet system and others, and the environments around them, and what their moons might be like in terms of their interactions with magnetic fields, with radiation, temperatures, all kinds of things. So this is just the beginning of our investigation into this whole type of object.
It's a new science. So this is an interesting question, and it may be a little bit difficult. Is it possible that this moon could have its own moons?
Oh, that is a great question and a difficult one. Well, first, I'll say anything's possible, as we've been discovering all kinds of exoplanets, first of all, things that we didn't know could exist, that orbit, so close to their star that, you know, they orbit within 1 day compared to our 1-year orbit. So things like this that we'd never even dreamed of. So an exomoon having its own moons is possible, especially when this moon is so massive that maybe it could, what we call, you know, use its gravity to capture other smaller bodies around it. Like Mars has 2 very tiny moons, relatively speaking, compared to our moon. So maybe there's some very tiny moons that have been captured by this moon and are orbiting, but we just don't have the right instruments to be able to detect them right now. And yeah, but it's definitely possible.
That could be cool. So we've been talking about Hubble and we've been talking about NASA's anniversary, and so NASA's been around for 60 years and Hubble's been around for almost half that time. How's our telescope doing?
Well, we're excited about Hubble. So as you say, Hubble's been around almost half the time that NASA's been around, and we just celebrated Hubble's 28th birthday earlier this year. Hubble's been working well because we have this terrific crew of people on the ground that are keeping it strong, scientifically working, and we've had several crews of astronauts over the years coming back to upgrade the telescope and service it, keeping it in tip-top shape. So Hubble is in great shape. We're getting some of the best science out of it now than ever before in its history. We're learning not only about the atmospheres of some exoplanets, but we're also learning about star systems, other galaxies, even the whole universe, the history of the universe. And we anticipate getting good science from Hubble for quite a few years to come. In fact, we are hoping that we overlap with the James Webb Space Telescope, which will launch in 2021. And overlap with that telescope for several years, because these complementary observatories are going to give us terrific science. They're going to cover the wavelength range of light from mid-infrared all the way through the visible colors that our eyes can see and on into the higher energy ultraviolet light. This gives us a great deal of information about whatever we're studying, whether it's exoplanets or planets in our own solar system, and of course other stars and galaxies. And we complement other missions. You know, Hubble is being used to complement the information that we're getting from probes that we're sending within our own solar system. For example, the Juno probe studying Jupiter in our own solar system is sending back information that we're correlating with observations from Hubble. We've used it along with New Horizons to study Pluto. We're using it with other missions to study things outside of our solar system and in the deep universe. So I think Hubble's in great shape and will be for quite a few years to come, and that makes me very happy.
That makes me very happy, but unfortunately this is the end of the show. If you want to know more about Hubble or about this exomoon, you can go to our website, nasa.gov/Hubble. We got a bunch of great new products up there. We've got an interactive timeline that you can see Hubble milestones. You can check out a 360 tour of our Space Telescope Operations Control Room. You can see where all the action happens. And we've uploaded hours of Hubble historical video for you to check out. So head to nasa.gov/Hubble, or you can find us on social media at NASA Hubble. And thank you so much for joining us, and a very, very happy birthday to NASA.